AI video generation with joint spatiotemporal modeling. Agenda: video generation approaches, Kling history, why Kling matters, video generation lifecycle. Getting started, basic workflow, spatiotemporal modeling. Video generation approaches. Generating video with AI means producing not just a single convincing image, but a coherent sequence of them that moves believably over time. If each frame is generated somewhat independently, small inconsistencies between frames can show up as flicker or objects subtly changing shapes. Almost every video generation model has to decide how tightly it models the relationship between frames, not just the content of each one. Any tool meant to produce genuinely believable motion benefits from understanding time as a core part of generation, not an afterthought. Generating a convincing single image is a very different problem from generating 2 minutes of consistent, believable motion. Frame by frame and joint spatiotemporal. A frame by frame approach generates individual frames somewhat independently, then relies on separate techniques to stitch them into consistent motion. Kling instead uses a 3D VAE that processes spatial and temporal information together as one unified structure, rather than generating frames independently and stringing them together. Frame by frame. Frames generated separately, stitched together after, prone to flicker. Joint spatiotemporal. Kling, space and time modeled together. Physically coherent motion. Problems with frame-by-frame generation. Single point of inconsistency. Objects and characters can subtly shift in appearance from one frame to the next. Motion can look flickery or unnatural when temporal coherence isn't modeled as part of generation itself. Physics like behavior, such as how objects fall or collide, is hard to get right without understanding time directly. Stitching together independently generated frames adds complexity without guaranteeing real consistency. Longer sequences make small per-frame inconsistencies accumulate into visibly unstable video. Misses out on the physical plausibility that comes from treating motion as a core part of the generation process. The Kling system, a text and image prompt, is encoded and combined with a 3D VAE that represents both space and time in one unified structure. A diffusion transformer denoises that joint spatiotemporal representation guided by the prompt to produce coherent motion. The result is decoded back into a full video with Kling's later versions adding native synchronized audio generated alongside the visuals. Other well-known AI video generation tools: OpenAI's Sora, Google's Veo, Runaway. Kling's advantages: joint spatiotemporal modeling produces motion that feels physically coherent rather than flickery. Supports both text to audio and image to video, like text to video and image to video generation from reference frames. Later versions generate native synchronized audio alongside video rather than adding sound afterward. Supports multi-shot storyboarding, connecting several shots into a longer, directed sequence. Character and prop consistency features help maintain the same subject across a generated sequence. Rapid iteration has pushed resolution, length, and frame rate significantly since its original 2024 release. Everything is modeled as space and time together. One huge benefit of this design is that, in Kling, almost every part of a generated video is shaped by modeling space and time as one unified structure. The 3D VAE doesn't treat a video as a stack of separate images. It represents spatial and temporal patterns together from the start. This is what allows Kling to capture large, believable motion instead of subtle frame-to-frame drift. Because time is built into the core representation, the model can reason about how something should move, not just how it should look in a single moment. This joint spatio-temporal architecture is the technical foundation behind Kling's reputation for physically coherent video. Prompts and keyframes. Prompt: the text description guiding the generated video. Keyframe: a reference image anchoring the start and optionally end of a clip. Frame by frame versus spatio-temporal. Conceptually, the old approach generates frames separately. Kling models space and time together. A simplified video generation request. A single request can generate a full clip directly from a text prompt. History: developed by Koshao Technology, a major Chinese short video and social platform company founded in 2011. Koshao's massive video platform, with hundreds of millions of daily users, gave it an unusually large trove of video data to draw on. Kling was first unveiled on June 10, 2024, generating text-to-video and image-to-video clips using a diffusion transformer architecture. The model iterated rapidly, advancing through several major versions with about 2 years of its original release. Kling 3.0, launched in February 2026, introduced a unified architecture combining text, image, audio, and video, along with native 4K resolution and multi-shot storyboarding. Why Kling matters? Physically coherent. Joint spatio-temporal modeling produces believable large-scale motion. Flexible. Supports text-to-video, image-to-video, and multi-shot sequences. Increasingly multimodal. Later versions unify text, image, audio, and video generation. Rapidly advancing. Resolution, length, and frame rate have grown significantly since launch. Data advantages. Data advantage built on top of one of the world's largest short video platforms. Widely adopted, used by tens of millions of creators and thousands of enterprise clients. The 3D VAE. Kling's 3D VAE compresses video into a latent representation that captures space and time jointly. Unlike a 2D VAE applied frame by frame, it treats an entire clip's spatial and temporal structure as one representation. This joint compression is what preserves motion coherence through the compression and generation process. Never assume Kling generates a video the way a camera captures one. It's constructing the entire spatiotemporal volume from a learned representation, not filming anything. Text or image input prompt 3D PAE spatiotemporal encode DIT refine the clip denoise output full video decode. A prompt is encoded into a joint spatiotemporal representation refined by a diffusion transformer and decoded into the final video. Getting started with Clinch. This leads us to the three steps that get your first video generated. Access the platform. Register through Clinch's website and app. Choose the generation mode. Pick text to video or image to text. Sorry, image to video. Write a prompt. Describe the scene and motion you want to see. Basic workflow. Prompting, directing, and extending. Some call prompt, direct, and extend Clean's everyday loop. Detailed prompts describing both scene and motion generally produce more controlled results. Keyframes let a clip start or end on a specific reference image. Multi-shot storyboarding connects several generated shots into a longer directed sequence. Character consistency features help the same subject persist across a generated video. Supports many workflows, short-form content, marketing visuals, pre-visualization, and creative experimentation. Works the same across the web platform and API integrations. Any questions? Thank you.